Okay, so this is Algebra 2 video on section 4.4b. We're going to continue where we left off last time on graphing parabolas. But remember, last time we talked about parabolas that were in vertex form. Vertex form meaning you might have y equals, there may be some a number out in front, and then you would have x either plus or minus some other number, we'll call it h, and that's in a parenthesis where it's squared. And then out at the end, you might have plus or minus some other number, we'll call it k. So in this case, we're saying that the a, the h, and the k, those are all just numbers that affect our parabola in some way. So to begin, if a quadratic equation, remember quadratic means there's an x squared in it, there's a squared term in it. If a quadratic equation is not in vertex form, okay, we know how to graph it if it's in vertex form, but if it's not in vertex form, you should change to vertex form by completing the square. Completing, I don't know if that's spelled right or not, the square. Okay, completing the square. So in other words, if you look at example 1, this is not in vertex form. How do I know that? Well, there's no parentheses squared, right? There's no parentheses squared. So I know it's not in vertex form, and I know it's a parabola because there's an x squared, but I don't know if it's moved up or down or left or right. I don't know any of that. So when I say I want to complete the square, that means I want it to look like some parenthesis squared. Now there might be a number out in front, there might be a number out at the end, but there has to be some parenthesis squared. And you remember we did completing the square before when we were solving, and this is very similar. You may remember in order to fill in the parenthesis, we always just brought down the x, and we said whatever sign is in the original, if that's a minus, then we bring down the minus. And then you may remember in order to get the number that goes inside the parenthesis, we take half of that x number. So if it's a 6, in the parenthesis we would put a 3. So I know it's an x minus 3, but here's the idea. Now, when you're doing this, you don't have to write all this out, but if this were being squared, if I were to take x minus 3 and multiply by x minus 3, I would get x squared minus 6x plus 9. I mean, you can multiply it out or you can trust me, but that's what I would get. And notice that's the same as what I have up here in that it's got the x squared minus 6x. But by writing it as a quantity squared, I've inadvertently changed what was originally a plus 10 into a plus 9. Well, we don't want to change the equation. We just want to make the equation look different. We want to change the form, but we don't want to change the overall value. So if I leave it just x minus 3, then I've changed it to be x squared minus 6x plus 9. But I want it to be a plus 10. So what do I need to put out here at the end that'll turn that plus 9 into a plus 10? Well, don't I need to add 1? Because if I add 1, now it's not plus 9, but it's actually plus 10. So what that means is the actual vertex form is this whole thing. It's not just x minus 3 squared. It's x minus 3 squared plus 1. And then, of course, once you have that, you know how to graph it, right? So this is going to be a parabola that's moved 3 units to the right, 1 unit up. Notice the number out in front is just like a 1, so it's the basic width of a parabola, up 1 over 1, and there's my basic graph. All right, if you missed the point, make the points bigger. Okay, so if I look at example 2, same concept. I want it to look like a parenthesis squared. And so what am I going to fill in the parenthesis? Well, it's going to be x plus, remember we always take half of the x number, so half of 8 is 4. Now, instead of writing all of that out like we did up above, I don't need to worry about the x squared and the 8x. That's not a problem. If this were squared out, what would the last number be? Well, the last number would be whatever 4 squared is, so the last number would be 16. But I don't want it to be 16, I want it to be 14. So what am I going to have to do to the 16 to bring it back to the 14? Well, wouldn't you just need to subtract 2? So that means the actual vertex form is y equals that parenthesis squared minus 2. And then how do we graph that? Well, It's going to be 4 units to the left and then down 2. Notice there's no number out in front, so it's like this implied 1. So it's the basic width of a parabola. And yes, our parabola is going to go off the graph. So what? That doesn't mean we did anything wrong. Okay. Not having great luck with graphing my parabolas today. Okay. So look at example 3. All right, well, this is a little different because notice there's a minus out in front. Now, I know that minus is going to make it open down, but I need to think about how does that affect my vertex form. Well, you can't complete the square, and you may remember this from last time. You can't complete the square if there's a number in front of the x squared. So before I can, I'm going to leave a space. Before I can get to parentheses squared, remember what we did last time? We said whatever is in front of the x squared, you need to factor it out. If I factor out that negative, then in the parenthesis I have x squared. If I factor out the negative, it's going to be a plus 4x. And I only want to factor it out of the x's. You may remember this from last time. We didn't factor it out of that last number, only the x's. So there's still this plus 1 out at the end. So on this line right here, we have not completed the square. All we've done is move that negative out in front. Now I can complete the square. Okay, so when I come down here, I'm going to keep that negative out in front. In order to fill in the parenthesis, I know it's going to be x. I know it's going to be a plus because remember it's the same as the sign up there. I take half of that 4x number, so half of 4 is 2. Okay, so here's what I need to think about. If this were multiplied out, if I were to multiply out this entire parenthesis, that last number when I square the 2 would be a 4. But notice there's a negative out in front. Isn't that negative distributed to everything inside? So really what I'm going to have is a negative 4 at the very end. If this were multiplied out and then I distributed a negative, I'd have this negative 4 at the end. But I don't want it to be a negative 4. I want it to be a plus 1. So what am I going to have to do to that negative 4 to get it back to a plus 1? Well, wouldn't I have to add 5? Because if I add 5, negative 4 plus 5, wouldn't that get it back to be a positive 1? So this is my vertex form. So when I graph it, I'm going to go 2 units to the left, 5 units up. 1, 2, 3. Oops, I only went up 4, sorry. 5 units up. There I am. Because of that negative out in front, I know it's opening down. And because it's like a negative 1, it's a down 1 over 1. So it's the same basic width, it's just opening down, right? Okay, look at example 4. This is the most involved of all of them. So I'm going to leave a space. I know I want it to look like a parenthesis squared. That's what it means to complete the square. But remember, we can't complete the square with that 3 in front. So first I need to factor out of 3. I'm going to have x squared plus 2x. But remember, we only factor it out of the x's. So I still have that plus 1. And keep in mind, I know I could factor out a 3x, but that's not what I'm trying to do. I'm just trying to get that 3 away from the x squared. Okay, so I have to keep the 3 out in front. And then when I fill in my parenthesis, it's going to become x plus, well, what is half of 2? Half of 2 is 1. Okay, so now we have to think about it. If this were squared out, forget the 3, if this were squared out, yes, I'd have the x squared 2x, that's not the problem. The last number would be 1 squared. Well, 1 squared is 1, right? But then once you square all of this out, isn't all of that being multiplied by 3? So then when you multiply by 3, really your last number is a 3, okay? I don't want my last number to be a 3. I want my last number to be a positive 1. So what am I going to have to do to that 3 to bring it back down to a 1? Well, I'll just subtract 2. And so what I have here is, this is my vertex form. You know, you can always check it. You know, if you're not sure if you did it right and say it's a test and, you know, you got to pass this test in order to graduate or something, you know, and you just have to really make sure it's accurate, you could always multiply it out. Like you could say, hey, if I were to multiply this out, leave the 3. If I were to square this out, I would get x squared plus 2x plus 1. If you want, you could go off to the side. You know, you could do x plus 1 times x plus 1 and see what you get. All right, so you'd have your 3, you'd square that out, and then you have that minus 2. If you distribute the 3x squared plus 6x plus 3, still have the minus 2. If you go ahead and combine the 3 and the minus 2, you're going to have 3x squared plus 6x plus 1. Well, isn't that what the original equation was? So I'm not saying you need to do this to check it. I'm just saying if you're ever not sure, you could always multiply it out and see if it's equivalent to where you started. Okay, I'm going to get rid of that. I don't want that to confuse anybody. So if that just messed with your head, then you can just ignore what I just said. Okay, and so now I'm going to graph it. I'm going to move this parabola 1 unit to the left, 2 units down. So there's my vertex. Now because of that 3 out in front, it's positive, so it's opening up. But because of the 3, it's going to be narrow. So up 3 over 1, up 3 over 1. So this is going to be a pretty narrow parabola that opens up. Okay, so today is about, yes, you're already supposed to know how to graph it if it's in vertex form. Today is about what if it's not in vertex form, you have to change it into vertex form. All right, hope that helps.